So now we're going to move on to 3.7b. So we're going to go back to a circle equation. So just remember, this is a circle. The radius is 1 because the square root of 1 is 1. And the center is 0, 0 because nothing's subtracted from x or y. If it said x minus 10 squared, then the center would be 10 something. Okay, so that's a circle. Remember, this crazy symbol means the second derivative. So that's what's new in 3.7b. Instead of just taking the first derivative, we're going to go on and find the second derivative implicitly. So in other words, the original is not solved for y, and we're figuring out the second derivative. All right, but before we can find the second derivative, we need the first derivative. So we're just going to take the derivative right away. So we did one like this. It's not too bad. X squared is 2x. Y squared is 2y, y prime. And then the derivative of 1 is 0. So then you subtract the 2x over and divide by 2y. And then the 2's cancel. So you got negative x over y. Okay, so there's the first derivative. Then to figure out the second derivative, I need to take the derivative again. So when I take the derivative again, I'm going to get the second derivative. So that's called y double prime. When I take the derivative of this, it's a quotient rule. So derivative of the top times the regular bottom minus derivative of bottom times regular top, and then all over the bottom square. So there's the second derivative. The only thing that is a little bit non-traditional is we don't like having y prime in our answer. So we'd like to get rid of that y prime. And the way you can do it is, over here you have an equation for y prime. Y prime is equal to negative x over y. So I can take that negative x over y and put it in place of y prime there. So y double prime is negative y minus, and then y prime is negative x over y times negative x all over y squared. Bless you. So the only thing new here is, instead of writing y prime in our answer, we're putting the equation for y prime in the place of there, the equation we got earlier. Okay, now this is kind of nasty because it's got double fractions. So the next thing I'm going to do, just to clean it up a little bit, is clear the double fractions. And the way you do that is you multiply by the double denominator. So since y is the double denominator, I'm going to multiply by y over y. Okay, so that comes out to, then that distributes to there and there. So that'll be negative y squared This is a time sign, so it doesn't distribute to these. It just goes with, it can go with either one. So I'm going to choose to go here, so it'll clear the y. So that's going to be negative x times negative x, which is plus x squared, except there's a negative here. So it'll be minus x squared. That was tricky there. So these y's canceled. And then I multiplied x times x and got x squared. Is everybody okay with that? And on the bottom, it's y cubed. Okay, I would be totally fine with this answer, but there's something really cute that happens, and it's pretty easy to show, so I'm going to show you. You can factor a negative 1 out on top. And then this equals 1. I know you would never do that, and that's fine. But I couldn't not show it to you. So again, this is totally fine for a final answer. But that happened, and it was easy to show, so I did it. Okay, so when you're taking a second derivative, that's the main topic of 3.7b. When you're taking a second derivative, you just solve for y prime and then do the derivative again. And you might have to plug in the formula for y prime as you go. All right. Okay, so we've got x cubed y plus y squared equals 15. And then what's going on here? I mean, you don't have to explain it, but how is it different than usual? Yeah, x and y are switched. Usually the derivative is dy dx, right? And this is dx dy. That's not a misprint. I'm doing it on purpose. Okay, so normally x is the variable on this axis and y is the variable on this axis. What that means is x is the input and y is the output. Or in other words, x is independent and y is dependent. Okay, but here the roles are switched apparently. So since it says dx over dy, that means y is the independent variable. Okay, so because of that, when you take the derivative, you're not doing d dx, you're doing d dy. So normally we write this, don't write this down. Normally we put d dx, and I haven't explained that notation fully. I've just said it means take the derivative. But more than that, it means take the derivative and the independent variable is x. So it's a signal about what the input variable is. So in this problem, the input variable is y, and so we're going to do d dy instead. Okay, so I'm going to work from the right to the left. The derivative of 15 is 0. Okay, now this time y is independent. So that means that this is not a disguised chain rule. Y is not a mess. So the derivative of y squared is just 2y. And that's because we're doing d dy rather than d dx. That gets back to the question you were asking yesterday, Bailey, right? Good. Okay, so then this is a little harder because it's product rule. So that's why I left it for last. So we have to do the derivative of the first thing. Now this is very bothersome. This is a disguised chain rule because x is the output. And since x is the output, that means there's a mess in place of x. So the derivative of x cubed is 3x squared times x prime. So that's the derivative of the first thing times regular second thing plus derivative of the second thing, which is just 1, times the regular first thing. Is everybody okay with that? So the real purpose of this problem is to just explain that d dx is a more deep symbol than just saying take the derivative. d dx is a symbol that means take the derivative and the input variable is x. And this means take the derivative and the input variable is y. Okay, so you just subtract those over then. So 3x squared x prime times y equals negative x cubed minus 2y. And then you divide everything over to get x prime by itself. And x prime is kind of a lazy notation for dx dy. Just like y prime. I just write down y prime, but the Khan Academy guy wasn't being lazy. He wrote dy dx every time because it's more descriptive. dy dx is more of a pain to write down, but it's more descriptive. It tells you the independent variable is x, the dependent variable is y, and that's the derivative. Okay, so here we have dx dy. Everybody's okay with that? All right, that's all I got.